In this lesson, we're going to talk about how to use the distributive property and combining like terms when we're solving equations. So the first thing you need to make sure you do is set up your Cornell Notes. Our essential question is, how do we apply the distributive property to when solving equations? So please take a minute, pause the video, and get your notes set up. The first thing that I want to define are like terms. I think most of you know what like terms are, but we need to make sure that we're very clear on this, okay? Like terms, I'm going to focus that just a little bit better. Like terms are terms in an equation or expression that have the same variable part or no variable part. And I'm going to give you some examples. At any point that you need to pause the video, please do that to make sure that you get the definition. When we combine like terms, all we have to do is add or subtract the coefficient, and the variable part stays the same. The variable part stays the same. Okay, so let me give you just a few quick examples. 3x and 5x are like terms. If my expression was 3x plus 5x, that would simply be 8x. All we did was add the 3 and the 5. Another example, 2x minus 5 plus 7x squared minus 6 minus 8x. I'm giving you kind of a long one because I want to look at a couple of things here. First of all, I want you to see that 2x and negative 8x are like terms. Notice I did not say that the term 7x squared was a like term. The variable part is not the same. So when I put those two terms together, that's negative 6x. I do also have another pair of like terms here, negative 5 and negative 6. So those would be some constant terms that don't have a variable part. That would be negative 11. And then we would just add the 7x squared to the end. This isn't the best order to write it in, but there's nothing wrong with it or inaccurate about it. Okay, so the next thing we need to identify is the distributive property. I think most of you are fairly comfortable with it, but I just want to take a time to define it or look at the algebraic definition and then look at some examples. When we do the distributive property, we are distributing over addition or subtraction. That's important because sometimes we just try to distribute when we're not supposed to. And what I mean by that is if I have a number, A, times B plus C, I'm basically going to distribute that A over an adding problem. And so then when I distribute it, it would be A times B plus A times C. And it's the same thing with subtraction. If I have a number or variable times a difference or subtraction, I can distribute that to every term, and so A times B minus A times C. So let's look at just some expressions that have that in it. 5x plus 3 times x minus 2. The directions here would say simplify because this is an expression. There is no equal sign, so it is an expression. The first thing we have to do is we have to distribute. The 3 is what gets distributed over the subtraction. The 5x is going to stay 5x for right now. We're going to say 3 times x, which is 3x, 3 times negative 2, which is negative 6. That would be applying the distributive property. And now let's take our knowledge of like terms. 5x and 3x are like terms. Notice when I'm boxing those, I'm making sure that I include the sign with it, because we've got to pay attention to the signs on the numbers. So this would be 8x minus 6, and that would be it. That would be the simplified expression. I want to look at one more expression before we go into an actual equation. Okay? And what I want you to notice about this one, I'm purposely giving you this that are a little bit harder, and it's harder in that it's got some numbers or terms out front. And sometimes that confuses us. And what I want you to see is that this is a -2. And so when we distribute this, we're distributing a -2. So it would be -2 times 3x, which is -6x, and then -2 times +4, which is -8. Okay? And so now let's look for our like terms. We've got 13 and -8 that go together, so that makes 5 minus 6x. Okay, so let's take this now and let's apply it to our solving equations. So a couple of steps I want you to think about when solving equations. Okay, is anytime we have an equation. This applies to any equation you ever see. The first thing you always want to try to do is simplify it. It just makes it easier. Now, simplifying means, do I need to apply the distributive property? And are there any like terms that I need to combine? This just makes it easier. Yes, there are ways to solve it without doing that first, but it definitely makes it easier. And then number 2, once we get it all simplified at this point, then we can look at solving with inverse operations. As we get into some more complicated equations later on, we're going to add a few steps in there, but these are the basic steps we're going to need to look at for now. Okay, so the first example I want you to look at is 2 times 3x minus 7 plus 4x equals 26. Okay, now I'm not going to worry about any inverse operations until I get this nice and simplified. So because we have parentheses, that's my clue that I need to do the distributive property. 2 times 3x is 6x. 2 times -7 is -14. Plus 4x equals 26. Really important that you take your time, show your steps. Now I'm going to combine like terms, so this becomes 10x minus 14 equals 26. And now we're down to just a basic two-step equation that you should be comfortable with. Add 14 to both sides. 10x equals 40. Divide by 10. X equals 4. This is my solution. It's my solution because it makes the equation true. I've gone over my time limit, but I want to go ahead and show you one more equation so that you have a good example. Okay, this one's a little bit harder because I have 2 sets of parentheses. So we're going to have to distribute the 3 across the addition here. So it'd be 3x plus 12. On the next set, notice this is a -5. So -5 times x is -5x. -5 times -1 is +5. And now I've got some like terms. 3x minus 5x is -2x. 12 and 5 makes 17. And now we're down to just a basic two-step equation, and I think that you can finish it from there. I would like to challenge you to try an equation on your own. You may not be perfect at it yet, and remember, that's okay. I don't expect you to be perfect until we practice it some more. Here is your entrance ticket equation for tomorrow, and so be ready to Write this down for me when you come to class, and I will probably have you put it on a sticky note and post it on the board.